Hello, I'm Zoe. In this video, I will present our paper, Efficient Image Restoration with State-Dependent Forward Diffusion. And the previous generative image restoration often built on diffusion, flow matching, and the diffusion bridge models. And our idea is to learn stochastic image restoration through a single forward process. And the key part is the state-dependent mean-reverting STE, which can be learned by a stochastic flow matching objective and enables few-step sampling. We start from the mean-reverting STE, which contains a mean-reversion term, mu minus xt, in the drifting function and has a closed-form solution. And reversing this process leads to an image restoration STE. And in this work, we further design a new STE with mean reversion in the both drift and diffusion functions, and we can directly use it for image restoration without reversing. And we can also obtain a closed-form solution for this STE. This closed-form solution allows us to sample any intermediate states xt directly, and then we optimize the stochastic flow matching objective. After training, we can get the clean targets and use it to solve the STE for image restoration. In addition, based on the analytic FOD solution, our method enables fast sampling via both Markov chain and non-Markov chain. Here are the specific algorithms for training and different sampling approaches. And in the experiments, we evaluate our method across tasks and metrics and compare with representative generative restoration methods, including diffusion, diffusion bridge, and flow matching. Here are some visual examples. And we further provide a comprehensive discussion and analysis on each important component of our method, including fast sampling, noise injection, and theta and sigma schedules in diffusion models. We will also provide an illustration of the diffusion process and compare it with the diffusion bridge models. And in summary, we present FOD, a state-dependent mean reverting STE for image restoration, and we show that this STE is electrically trackable and can be learned by stochastic flow matching. FOD also enables few-step restoration while maintaining strong image restoration quality. Our approach finally achieves highly competitive performance on diverse image restoration tasks. Thank you for your attention.